Alrighty, welcome everyone to day 8 of Advent to Code. A few seconds here. Code is already set up, waiting for the inputs. Let's get into day number 8. You're still riding a camel across Desert Island when you spot a sandstorm quickly approaching. When you turn to warn the elf, she disappears before your eyes. To be fair, she just finished warning you about ghosts a few minutes ago. One of the camel's pouches is labeled maps. Sure enough, it's full of documents, puzzle inputs about how to navigate the desert. At least you're pretty sure that's what they are. One of the documents contains a list of left and right instructions, and the rest of the documents seem to be describing some kind of network of labeled nodes. Seems like you're meant to use the left-right instructions to navigate the network. Perhaps if you had a camel follow the same instructions, you can escape the haunted wasteland. After examining the maps for a bit, two nodes stick out to you, AA and ZZ. I feel like AAA is where you are now, and you're following the left-right instructions to reach CCC. This format defines each node of the network individually. Cool, starting with AA, so it's going to be the left and right. Cool, of course you might not find ZZ right away. If you run into left and right instructions, repeat the whole sequence instructions necessary. ZZ. Starting AA follower, how many steps to... Okay, so this one actually seems pretty straightforward. Okay. Pretty straightforward problem. Parse it, and then run until we reach ZZ. So what we're going to need to do is const instructions. It's going to equal input. Actually, we need const lines input split on new line. Then it's going to be lines 0 split on each character to get our instructions. And then we're going to need to do const nodes. I don't know. Sure, we'll go with nodes. And it's going to be lines slice from 2 on, and then map this. Actually, we're going to call reduce. That way I can do something like this. So we can get nodes, line, and then I can do this. Initiate this as this. I think I have to do this just so it knows it's a key string. Actually, let's do const node. I'm going to do it up here just to make life a little bit easier because... Goodness. What I want to do is I want in here to have left string... Oh, const notes type. And right string. As node. Okay, and so we're going to return no. Actually, we're going to return nodes, and then it's going to be we need to parse the line. So these are all 3, right? It makes life much easier. I can just do const, this is going to be the, I'm just going to say node. And it's going to be line substring 0 to 3. And then we're going to do left. It's going to equal to line substring 0. So it's going to be 1, 2, 3, 4, 5, 6, 7 to 10. And then right is going to be 7, 8, 9, 10, 11, 12 to 15. Hopefully, I parse these correctly to where I can then do node, left, right. Fingers crossed we did that correctly. All right, so now we have our nodes here, and so all we're going to do is we're going to have we're going to have a while loop here. So we're going to have let current node equals AA. And we're going to do while current node does not equal ZZZ. Do this logic. Ignore for the whole file. So we're also going to have let instructions run equals 0. Instructions run plus plus. Actually, that's me after. Yes. Because what we're going to do is then do instructions. Are going to do const instruction equals instructions. Spell right. Instructions run modulus the length of this. That way we correctly go looping around it. And then we're going to do if instruction. We're also going to need node choices is going to equal nodes current node. If instruction equals R, we're going right. We're going to set current node equal to node choices right. Otherwise, we're going left. And that should be all we need to then console log instructions run. Right? Right? One shot it. Let's go. 807. Not bad either. The sandstorm was upon you. You aren't any closer to escaping the wasteland. You had the camel follow instructions, but you barely left your starting position, and it's going to take significantly more steps to escape. What if the map isn't for people? What if the map's only is for ghosts? Are your ghosts even bound by the laws of space-time? After examining the maps a bit longer, your attention is drawn to a curious fact. The number of nodes within the names ending in A is equal to the number of ending in Z. If you're a ghost, you probably just start at every node that ends with A and following all the paths at the same time until they all simultaneously end at nodes that end with Z. Okay, here are two nodes, starting nodes, 1A, 2A, because they both end with A. Follow each left-right instruction. Use that instruction to simultaneously navigate away from both nodes you're currently on. Yeah, 1A and 2A. You choose all the left paths leading you to... Okay, I think I need to see the input for this. So we need to start on all the ones that end in A. So it's going to be the same concept, except that we need to have multiple that we're starting on. Current nodes is going to equal nodes filter object keys nodes filter and ends with A. So here's our current nodes. So now we need to do current nodes map. This is going to be while current nodes filter and ends with Z length is greater than 0. So now what we're going to do is we're going to do a map. And this map is actually just going to be the exact same thing, except that we don't do current node, we actually just going to return. Return. Actually, I can make this a little bit easier and do return like that. Because I'll go through each current nodes. We need to make sure we update the current nodes correctly. Oh, dot right. And in theory, that should give us part 2. Nope. Okay. Oh, it's not filter. Or it is filter, but it's that. Well, we can sit here and hope eventually it gets the answer. I messed up. That's never going to end because I was never doing that. I'm trying to I'm letting it run, but also I'm trying to make sure I didn't make any issues, make any errors here. Okay, let's do it with the example, I guess. Okay, and then we're also going to ignore part 1. Okay, so it does work. It does work. Question becomes, how long do I want to give this? Are there any improvements I can make? Could this be a GCF, a greatest common factor, where we find for each node how long does it take to get to Z? Okay, let me do this. Let me do N and I. If const next node equals that. If next node ends with Z, no, don't return, console log I and instructions run +1. Gotcha. Okay, so it is working. It's going. Let's. I'm just call it GCF right now. Equals array from length of current nodes. Fill with fill. We're gonna fill these all with 0. And so we're gonna do GCF. Last value is equal to GCF. I if GCF or if last value does not equal 0, Actually, it doesn't matter if it is 0. We can just do a console.log of last value, this minus that, as number, and then we can go ahead and do GCF I is going to equal instructions to run +1. That can go away. Add a line. Okay, let's try this. Oh. What I want to see is that these are kind of repeating. How about this? If we're gonna trust the system here. We're gonna trust the system. Because they're all starting. I don't think we can trust the very first one. We got to do it. They got to go one full. GCF temp, GCF temp. Const diff is going to equal that if GCF temp does not equal 0 and GCF I equals 0. This is a way to get the very first time it's happened. We're gonna go ahead and do this. Woo. On GCF. Okay, and then we're gonna do while GCF filter n does not equal, or n equals 0, length is greater than 0. Okay. And then this is gonna be console log GCF. Let's see how this goes. Okay, so we get this, this, and that. Okay, so what's so it's a GCF, so it's just gonna be reduce product steps, and we're gonna it seems low, but 1, or it's gonna be prod times steps. All right. Oh, that's because I messed that up. There we go. All right, is this gonna work? Nope. Nope, nope. Console.log. I mean, is the diffs, are these all? I'm gonna have to stop this execution. Oh. Go back to file current nodes. Nope, length is greater than 0. Go back to that. That way it kind of runs forever again. Why? Why did I only get 3, but now I have a bunch? Why do I have 6? Okay, well 0. Okay, no, it is. I am right. Okay, so I am right. It's just ending prematurely. Why is it ending prematurely? God dang it. I messed that up. Try that again. I see why I'm wrong. Okay. It wants me to find the product, right? It's not, okay, wait, it's not GCF. Hold on, can I, it's not greatest common factor, it's least common multiple, it's LCM, right? I'm not gonna cheat, I'm gonna put these into an LCM, I'm gonna see if I'm right. I might be right, and these being an LCM. I forget, I mean, it's not, adding an LCM isn't, these call multiple. Right. Okay. Oh yeah. Sorry, I thought that. Okay, never mind. I thought it was doing something else. Which means it would be. Which means it would be this. Okay. I got it right. I just need to figure out. I just need to write an LCM algorithm. Oh man, it's been way too long since I've wrote an LCM. Okay. Since I know it, let me take a break. Let me write the LCM, and then we'll come back and I'll explain it and go through it all. So, one moment. Alrighty, so I went out and unfortunately I did not write this LCM method. I actually found it online. I thought about writing my own LCM, but it's been a while, and honestly, once you look up I don't know off the top of my head, so I've had to look up the math for it. And once I looked at the math, honestly, I would have wrote it, and I just want to go to bed. So I found this. I did change it up from what I found to kind of condense it a bit, but basically the LCM use the greatest common. What's the D in GCD? It's not greatest common something. Well, here's the site I got it from. Greatest common divisor. Thank you. Oh my goodness. Greatest common divisor. I noticed like D was like for division, but I couldn't think of it. Greatest common divisor. So that's how it works. It just uses that. Again, it is math. I just don't remember because it's been a few years since I graduated college. So at any rate, that's there. now we have this totally solving it and working. It's not pretty fast, but at any rate, day 8, we are given this input of nodes and a direction. From that node you can go to get to new nodes. So it's to the left, to the right, to get to these nodes. Our input is also started with a long list of instructions. So first we go through and parse that. So we take our lines, there's the first index of the lines in our instruction sets, can split it to get every character by itself. Then we go through and parse our nodes out. Luckily, these lines are all the same. It's a three character node. These 3-character node, 3-character node. So I can actually split that nice and easily by just hard coding the locations of the node left and right to build up this node map. For part 1, all we gotta do is keep track of our instructions that have been run. Start at node AAA, and then while we are not at node ZZZ, get the incur instruction to run, which is our instructions that we've already run, modulus of the length of the instructions. That way it loops around when we get to the end. And then we simply get the node choices for the node we are at. So given, if we're at AA or wherever, get these nodes that we can go to, and then get the node for the instruction. So right, get the right node, left, get the left node, increment our instructions to run. And then once we reach ZZ, end this while loop and output how many instructions have run, take us from AA to ZZ. Pretty simple. Part 2, very same concept, just instead of there being one node you're starting at every node that ends with A, and you're going until you reach every node that ends with Z. You could brute force it, but it'll take a while. But there's a simpler thing, is you trying to find the pattern. You see how long did it take you to get from a node that ends in A to a node that ends in Z for each starting node. Which what this does, again, same concept, but this is going while there's a GCF in this. Ignore that for the moment. But for every node we are at, map it to basically go to the next node. Again, it's just like the last one, get the instruction, find the next node, get the next node. And then here what we do is we check to see if the next node we are at ends with a Z. That means that this node of the array of the set has ended, and we can check to see if our GCF has already been calculated. If it hasn't, so it starts at 0. If it is 0, we simply just set the GCF, which is going to be used for the greatest common factor, to be the instructions that recur. At. Of course, we don't increment it till after, so we add 1 here. But then while every node does not have a GCF, we keep running this, and then once every node has gotten from A to Z at one point, we stop running and we do our LCM of these GCFs. So basically you take all of them, you multiply them all together, but then you also divide by the greatest common divisor. That way you get the least common multiple, and there you go. So yeah, some math. Honestly, it's pretty straightforward, and you could brute force it. It'll just part 2 will just take too long. So that's why you have to use the greatest common factor logic for that to do that, but then also gotta get the LCM, least common multiple, from the greatest common factor. Math, yes. But anyways, hopefully that made sense. Thank you guys for watching. I'll see you guys all tomorrow for day 9. See you later. Peace out.